Hello, welcome back once again. Today we have this strange looking integral which looks almost unsolvable, right? But don't be surprised that I provided the solution to this problem. We have the integral of x raised to the power of dx minus 1. Let's see how it goes. First, let us recall that a raised to the power of b can be written in the form e raised to the power of the power b times the natural log of the base, which is a, right? Therefore, the expression will become integral of x raised to the power of dx minus 1, which is equal to, using this identity, that becomes integral of e raised to the power of dx times the natural log of x and then minus 1. Now let us recall this Taylor series expansion for e to the power of x. So e raised to the power of x is equal to sum, as n goes from 0 to infinity, of x to the power of n divided by n factorial. And this is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus and so on. Therefore, this expression here will become the integral, so e to the power of dx natural log of x, using this, that will become 1 times the natural log of x dx plus the natural log of x squared times the dx squared divided by 2 factorial plus the natural log of x cubed times dx cubed divided by 3 factorial plus and so on, and don't forget to have minus 1. As you can see, the positive 1 and the negative 1 get cancelled. Now we know the differential here is an infinitely small number that tends to 0, right? So the limits will tend to 0. So this will be equal to 0, and this here will be equal to 0, and so on. Therefore, we are left with the integral of the natural log of x dx, which is equal to this strange looking integral, the integral of x to the power of dx minus 1. Then, to evaluate this, we use integration by parts property. Here, we're going to let u equals the natural log of x. Differentiating both sides, we get du is equal to dx divided by x. Again, we're going to let v equals the integral of 1 with respect to x, giving us x, so that dv is going to be equal to dx. Therefore, this integral will be equal to uv minus the integral of v du, right? So this is going to be equal to uv is giving us x times the natural log of x minus the integral of v. V is x times du is equal to dx divided by x. So these both get cancelled. So here this is going to be equal to x times the natural log of x minus the integral of 1 dx is giving us x and then plus c. So therefore, the strange looking integral, the integral of x raised to the power of dx minus 1 is simply equal to x natural log of x minus x plus c. And that's our solution. Thank you for watching. If you enjoyed the video, kindly subscribe, also like, comment and share.